I was there when it was saying. Download it. Oh, then you have to install.
As I mentioned earlier, that now we earlier examples of addition subtraction we have used hexadecimal values, but now we want to actually solve decimal values. So you know that we actually learned this BCD when we actually started revising on the numbering system. We actually know that decimal digits are encoded using 4 bits, right? That's BCD. That means the maximum is 9. 9 is represented using 4 bits. Because decimal, the range is from 0 to 9. And if you represent it in bits, for one decimal digit you need 4 bits. That is binary coded decimal. That means for the number 9 you will have the binary code 1001. You all get it? So the same thing, when you, that binary digit, we will be using compact representation, when you will use hex numbers as a compact representation. So 9, if you convert to hex, is actually same. Decimal 9 and hexa 9 are the same. They are same until 9, right? So you can represent decimal numbers using hex. So even though we write here hex 24, what we are actually trying to do is we want to add decimal 24 with decimal 67. So what we are doing now is we are representing decimal numbers using hex format or using hex base number. So when you add 24 plus 67 in decimal, what is supposed to get? In decimal, 24 plus 67 is supposed to get decimal 91. The problem is when you perform addition, take note that we actually perform addition using hex number. So when you add 4 plus 7 is 11, right? So you will get B, and this one is A. Does this match with this thing? No, so that means even though we want to add decimal number using hex number system, the answer that we are getting is out of decimal range. B is not decimal range. So we have this problem. So let us look at another example. 36 plus 47 in decimal, what is supposed to get? Supposed to get 83. But then when you add this one, you get 13. 13 is D. This is again the answer. You have a character which is not valid in a decimal number. So that's another problem. How about this one? This one 29, 47, and you get 76. When you add this one, this is 16. 16 minus 1. That's 6. 7. The answer is valid. It's a valid digit, but the answer is wrong. So you might have learned this when you actually try to solve decimal number using hex digit. You have to make decimal adjust. Have you ever learned decimal adjust? No. Really? Seriously, no. Or simply only. No, in digital logic you should have learned what? Let me think. But still no. How you all never learned that in digital logic? It is impossible. It is impossible using this word. Really never didn't learn about decimal adjust. Come again?
The term.
Oh, the terms you do not know. Okay, we want to solve decimal number. we are using hex. What is the difference between these two? How much is the difference between decimal and also hex? 6. So there are two conditions. Decimal adjust means you will be adding hex 6 to counting the number. No, you have to add 6 to get the correct answer. So there are two conditions where you have to add the hex 6. The first condition is, maybe you can write if you want. The first condition is, any digit which produces a value more than 9, you have to add 6 to that digit. I mean, do we need to add 6 to this digit? No, this digit is valid. This digit, is it a valid decimal? No, since it's not a valid, you have to add 6 to this digit. So this one 0 lah, only. And add. So when you add this, this is what we call as decimal adjust. We are performing the adjusting. So B is what? 11, right? 11 plus 6, 17 exceeded base number by 1. Okay? You get the correct answer now? So what is the first condition? Add 6 to which digit? Any digit which yields a number more than 9. So if this one yields more than 9, you add 6 to this digit. You have to add 6 to that particular digit. So that means if this one more than 9 and this one more than 9, 6, 6. Then, get it? So again, this one, do we have to perform decimal adjust?
Yes.
To which digit?
To D.
This one. Why? Because it has exceeded 9. So you have to add. This one 7, do we need to add 6? No need. What is D? 13. 13 plus 6? 19. 19 minus 16?
3.
You get back the same answer?
Magic.
Here, the last one. Both are valid. So that comes the second condition. The second condition is add 6 to the digit which causes a carry 1 to the next higher digit. That means add 6. Out of these two digits, which one is causing a carry to the higher digit? This one, right? This position digit is causing a carry to next higher digit. So you should add 6 to this digit. So when you add 6 to this digit, what's the answer that you get? 70. Do you think? So this is what we call as decimal adjust. So what are the two conditions again? The first one is?
Add 6 to any digit which is more than 9.
Second condition?
Add 6 to digit that causes carry to the next.
Yes. So these are the two conditions that you have to add 6 to. So this adding 6 is known as decimal adjust. Is it okay? Any question? So look at this example. Let data registers hex 24 and 25 holds BCD numbers. That means the content of hex 24 and 25 are decimal number. The following instruction sequence adds these two BCD numbers and saves the sum in hex 30. So the same step, you move hex 24 to working register. Can you all imagine this? Hex 24 and 25. Basically, it's actually hex 24 plus 25, store the answer at hex 30. Simple, same thing. But there's one additional thing here. So you move the content of hex 24 to working register, and then you add the content of working register to hex 25, you'll have the answer right. Now this answer, because we are operating, remember, when it does like that, we'll get answer something like this. Hex answer. So before you store, the answer is actually here, right, in working register. That means this answer is akin to this one, 8B. 7070. It could be either one of these conditions. So before you store the answer at the location that it is required, you perform decimal adjust working register. So this instruction is decimal adjust working register, which means this one you have no choice but to put the answer in working register. If you put this in file, there is no DAF, there is no DAF, there is only DAW, decimal adjust working register. So with the answer you must store at working register. Before you store the answer at the required location, you must perform decimal adjust. What is decimal adjust will do? It will actually check. It will automatically do this or do any of one of those. So you will get the correct answer, which is valid in decimal, and you can store it at hex. So this is the same like the previous addition. So how you know when to use DAW? Now in the question, look carefully. If the question says add two decimal numbers, that means your mind should automatically think of decimal adjust. If they never say add two decimal numbers, they say add two values, hex this one and hex this one. So that means that values are in hex. If the question says add decimal this one with decimal this one, so it is BCD. So in that way, the steps are the same, right? Normal addition. Only thing you have to add this one. So this is for a single byte. You have any question on this? Any question on this? So what if we have more than a single byte? The same principle. The same principle that you do. Each time before you store into the answer, if you see it has the same format. This one is the same, this one is the same, this one is the same, this one is the same. For the first one, before you store the answer, you must perform decimal adjust. The second one, of course you use add WFC because there's a possibility of having carry, right? The same thing you do, but before you load into the answer, you must perform decimal adjust. The third one is the same. You must add WFC and you must use decimal adjust. And also the fourth one.
So basically just moving into the file register, that's where they do. Before moving it into the file register.
Before moving to the final destination, that means the destination which requires the correct answer.
If, for example, the destination is file register, working register, so
Then you just perform it in here. No? But of course, in addition, that wouldn't be the case because you'll keep using working register. But that's the answer to your question. Yeah. So you can have this habit of drawing lines like this so you can see the different segments. You see the pattern, they are the same as the adding more than a single byte addition, right? The only thing you have addition is decimal adjust working register. The rest the format are the same as more than a single byte addition. Any question on this? Again, all these things are best for you to actually try it out. This Thursday we have quiz and I do not know what I'm going to ask. But that's yeah, definitely they're going to be on the board. It could be anything. Could be anything that you cover until now. But definitely macros will be there. Okay, I think we'll take this as the last example. So the next part is about multiplication. Don't worry, there is no decimal adjust or subtraction. It's only addition. So the next thing you're going to do is multiplication. So PIC18 has two instructions for multiplication. One is multiply the content of working register with file register and multiply literal with working register. Only got two instructions. Now take note that whenever you perform multiplication, single byte multiply single byte, the answer will get double byte. Single byte multiply single byte, the answer will get double byte, 2 bytes. So for these two instructions, whenever you multiply, take note that the answers will be stored in these special function registers. They are known as product high and product low. By default, whenever you use any one of these multiplication instructions, the answer you get right. The answer will be stored in product high and product low. It cannot be stored in working register, it cannot be stored in this file register because working register is single byte and this file register also single byte. Same goes with this one, the literal going to be single byte and working register is going to be single byte. So when you multiply, it is not possible for you to store back in working register or the file register. So therefore they have a dedicated register pair which is known as product high, which is 1 byte, and product low, another byte, so it is double byte. Understand? So the multiplication of numbers larger than 8 bits must be synthesized. So I'll show that in a while. So let's look at this one example. You want to multiply the content of hex 10 with hex 11. That means a single byte multiply single byte. So if you want to multiply single byte, in this case you have to use multiply working register with file register because there is no instruction multiply F with F. There's only W with F and also L with W. So in this case, if you want to multiply these two, it is F multiply F. But since we don't have one of it, we have to move it to working register. And then you can perform multiply working register with file register. Note that there is no destination here, right? So let's say if this example requires you to store the answer at hex 20 and hex 21. After you perform this instruction, automatically the answers will be stored in product high and product low. So what you have to do, you have to move FF product high into the higher address and product low to lower address. Get it? So next thing, let's see what happens if you want to multiply more than a single byte.
Yeah. So this is the example that we saw just now. Multiplying single byte actually will give double byte. But take note that when you use the instruction just now, automatically the answer will be stored in product high and product low. So if the question requires you to store in a different location, you have to move FF. If it is required to be in another location. So this is for single byte multiplication. If you are performing more than a single byte multiplication, you have to perform synthesis. So let's say double byte multiply double byte. See how I perform.
This one multiply with this one is like normal multiplication digit. This one multiply this one, you'll get double byte, right? So you will get double byte. This one multiply with this one, you get double byte, but it's always shifted by one, right? This one multiply with this one, you get double byte, but it's in the same row. This one multiply with this one, you get double byte, it's always shifted by one. So the final answer I get 4 byte. So this is what we know as synthesizing the answer. So here, when you do multiplication more than a single byte, you have to perform synthesis like this. This one will come here, and this one multiply will come here. This one will come here. First digit when you multiply, you get double byte. This one multiply the other one, you get double byte but shifted by one. This one multiply this one, you get double byte, same row. This one multiply this one, you get shifted by one. If you notice that, then later on you have to perform addition, right? You have to perform LWFC. So this is like accumulative of what you learn for this. So let us take for example, let's say this is x10, x11, x12, x13. Of course you can actually use data directives to actually assign a name for them. Shall we assign name or you want address? Address is fine. So let's say the final answer is required to be stored at x40, x41, x42 and x43. So here you have a lot of registers, right? Now to store these values in these registers you can use any dummy file registers which is not being used. So let's say I'm going to continue, I'm going to use this one 14, 15, 16, 17, 18, 19. Actually it's supposed to be after 19 supposed to be 1A, but I'm just using this like. Take note, I'm not, after 19 supposed to be 1A. Here I just use 1 here. Thank you. 1A and 1B. Okay. So let us see how we can actually solve this in instruction. So the first one, this one, let's say this is number 1, but this will be lower byte. This will be number 1, higher byte. This will be number 2, lower byte. This will be number 2, higher byte for illustration. So you know that this first one is actually number 2 minus this is actually as multiply, right? This one. Then this one and this one is the next one. This one is n1 high and low. And then n2 high minus, sorry, n2 high multiply n1 low. And then n2 high multiply n1 high. These are the four things, right? So we have to solve one by one to solve this whole thing. So let's try to do the first one. In order for you to do this one of it we have to use this instruction. We have used multiply working register, file register. So we have to use this instruction. You all get it right? The other instruction actually multiply literal with working register, so we're not doing that. We're going to do this. So that means one of it you need to move to working registers. So now we want to solve this first one. So the first one, or any one of it, you can actually move to working registers. So let's say, so assume that on top I have declared all my program start template and everything. So the first thing is you're going to move the content of x10 to working register, and then you're going to multiply with which file register? 12. Where's the answer stored? Whatever is the answer, we stored product high and product low, right? So the product low one is supposed to put it here, right? But rather than putting the product low here, this one is not adding with anything. So straight away we can move product low to x40 without using this. You all get it? So this one we can skip. So we can move the content of product low straight away here. So you can move FF product low to x40. Product high is supposed to load it here. You need to load it here because they say you need to add them up. So where do you product low have to go? x50. So you have to move FF product high to x15. So the first one done. So this one central line. This one we load to do. That the first one. Now the second one, N1 high, which is actually x11. So you have to move x11 into working register, and then you need to multiply with x12. Now, where the answer will be? Product high, product low, right? Product low is supposed to shift it to x16. Product high is supposed to shift it to x17. Is it okay? So you have loaded the value inside here and also inside here. Any question up to this point? You want to follow? Then what's next? We're going to do this one, right? N2 high with N1 low. So we can move x10 into working register. You can multiply working register file register with x13. Product high, the answer is product high, product low. So product low is supposed to move to 18. Product high is supposed to move to 19. So you move FF product low to 18. Move FF product high to 90. So this one and this one. And then the last one, which is N2 high, with N1 high, so you can move 11 into working register, multiply register with 13. So here, the low you're supposed to move it 1A.
High.
But the high, instead of putting here, you can simply put it here and here.
43.
So this one we can skip, we can simply put it 43. So
Move FF.
move FF,
Product low.
product low to
X.
1A,
Move FF. Product high to X43.
43. done until this point. Now this first byte answer we got, this one also we load ready, but this one we need to get the answer right. So this one you need to perform the addition. So remember the earlier example, the 3. So you can straight away add these two, store the answer working register, add with this one, store the answer working register, and move from working register to 41. So how do we write that? So move F X15 to working register, and then you add working register file register with
X16
X16, store the answer at
working register.
working register, and then you again add working register file register with
WFC.
not WFC, because you are still adding in the same byte. WFC is the next one. With X
18.
again the answer you store in working register. And finally what you do? Move WF to X41. So this one settled. Now when you add this, there's a possibility of having a carry on this side. So the first one, move F X 17 to working register. Now you add WFC X 19 to store the answer in working register. This one not necessary lah, but if you want to put WFC also you can, no problem. It's not a problem.
X1A
1A, you store the answer in working register.
Move
And finally you move WF to X40 42. Done for this one. Are we done?
Yes.
No. When you add this one, there's a possibility of having carry here. Right? This one will have a carry. So the last, this portion, there's no content to add. The only thing that you want to add is you want to add the carry only. So how do we do that? How can we just add the carry only? The only instruction that allows us to add carry is add WFC, right? This is the instruction that we can use. Add WFC. What we are interested in is only these two. We are only interested in adding the carry to the file register. Working register we are not interested. So what we should do? We should make this 0. So what you can do is you can clear F working register. So I'm clearing F working register. And then what I do, I'm going to add the content of working register. Content of working register is 0. Why I need to make it 0? Take note that the previously working register got some value.
Yeah.
So you need to make it 0. Actual thing I'm interested in is actually to add the carry, if there is carry, to 43. So I'm going to add to 43. This one, what's the destination? Yes, this one should be F. If there's a carry, it will add. If there's no carry, it will add 0. So this is only for double byte. If you have 3 bytes, your answer will be 6. So look at this. Have you noticed that this is same, this is same, this is same, this is same? So what can you do? Yes, you can actually use macro to simplify this. Of course, this one you can use macro. This one, if you want to call macro, can but it's just 2 lines. So from here, this example, you can see that whenever you have something repetitive, you can actually substitute it macro. If you see what are the things changing here, the only thing changing is this one, this one, this one, and this one. That's what changing, right? You see? This one, this one. The rest are same, right? So which means you can create a macro, but you take 1, 2, 3, 4 arguments. You take in 4 arguments, and you use it for this one, this one, this one, and this one. They are the same. The only thing changes, you see, is this one. This is the only thing which changes. So you can actually create a general macro which receives 4 arguments. You can call the first one, you can pass 10, 12, 40, 15. You call the second one, you pass 11, 12, 16, 17. Third one, fourth one. So try. From here, try to do that. Try to use macro. There's only one macro. For the addition, also no macro because the second one has NWFC. So for your information, multiplication like this will never come on factors
Yes.
because it's too long. I have not solved it. Why this question not so popularly asked is because the steps are too long. But it can be given as an assignment. They can. Okay, thank you very much for coming. It's a question. I'll see you all tomorrow morning.